Circuit board fabrication of metal core PCBs. The circuit boards composed of metallic cores is known as metals PCBs, and it is commonly utilized in LED devices. Metal core PCB is harder to manufacture than FR4 and can be more costly. Metal core PCB, MCPCB, or Insulated Metal Substrate, IMS PCB, would be a technique created to address the FR4 substance's thermodynamic constraints. If your boards must operate in a high-temperature condition, metallic core is a stronger option than FR4. Insulation metal substrate uses a unique insulator with a higher thermally conductance to offer electrically isolated among the copper and the metals cores. Metal core PCB manufacturing is the process of designing and fabricating printed circuit boards, PCBs, with a metals core to be used with lead-based solid-state illumination as well as other technologies that requires energy dispersion. Because adaptive elements could cause hotspots on an FR4 printed circuit board, another type of cooling is required to ensure acceptable working conditions. Thermal vias underlying heat-generating elements, energy sources, can be used to transmit heat from the element, upper surface, to the base PCB layer, where it could be dissipated by a heat sink. Manufacturing of metal core PCBs. Metal core PCB manufacturing offers a slew of advantages for a wide range of purposes. Because MCPCBs feature dielectric polymers layers as well as higher thermally conductance levels, they could attain a low heat resistance. Metal core PCB manufacture results in a solution that can transmit heat 9 times faster than a standard FR4 PCB. The laminates of MCPCBs disperse heat, ensuring that heat-generating aspects stay cooler. As a result, such elements have a longer working life and better efficiency. The metal cores must first be drilled to enable layers transitions, avoiding causing a short circuit in multilayered dielectric stacks. To begin, slightly larger holes are drilled into the metallic surface, which are then filled with insulation gel. The gel will be cured and solidified, allowing it to be plated with copper in the same way as a normal via can. The remainder of the stack is compressed and joined to the metallic surface, and then through holes are machined in the stack up, which is then plated and cleaned. Due to the existence of a metallic surface in the stack up, metal core PCBs should follow a specific method. If the circuit is a single layer board with no layers transitioning back to a metal frame, the normal FR4 circuit board fabrication procedure of pressing and bonding the insulating surface to the metal cores could be employed. Purposes of manufacturing of metal core PCBs. Metal core PCB manufacturing has a plethora of new uses as a result of the acceptance of new technology. This technique is effective for situations in which elements create a lot of heat and can't be chilled utilizing traditional fans or other cooling techniques. MCPCBs are used in solid-state lighting to achieve a higher level of luminosity with few LEDs. Despite the numerous benefits of lead-based solid-state lighting technology, they emit considerable quantities of heat. As a result, metal core PCB manufacturing is beneficial for purposes such as automobiles, lights, fixtures in basic converters of energy, mechanical, telecom, energy accumulations, and great charge controls, photovoltaic security on the street, brightness, street lights, etc. Advantages of metal core printed circuits boards. Metal cores PCBs have several capabilities over ordinary core components, including the capability to use a dielectric polymer with a high thermally conductance for decreased thermally impedance. A metal core PC board can transport sound up to 9 times quicker than a normal FR4 lamination. The core materials used by MCPCB are great at dissipating heat and preserving essential heat-generating equipment cold, which can improve effectiveness, productivity, and lifespan. Benefits of backlighting: the insulating impact of an iron core metal PCB, the brittle ceramic substance is replaced, suitable for putting on the wall, decreases labor and operational costs, and enhances product high thermal stability and structural qualities by replacing elements such as the heat sink. All are the benefits of using metal core printed circuits boards. Whenever the energy from an LED was never adequately dissipated, problems happen, and LED's lighting production is diminished, as well as degeneration when the heating stays stagnant in the LED packages. The goal of an MCPCB would be to effectively evacuate energy from across all current integrated circuits, not just LEDs. Among the ICS and the heating element, the aluminum bottom and thermal conducting insulating layers operate as bridging. Numerous heat sinks on top of surface-mounted equipment are eliminated since one singular heat sink was installed immediately to the metal foundation. The fundamental feature of the materials is thermally expansions and contracting. Nevertheless, various CTEs have varying thermal expansions. Aluminum and copper offer distinct advantages over standard FR4 in terms of thermal conductance, which can be as high as 0.83.0 W/C. The dimensions of a metal-based PCB are steadier than insulator substances in terms of directional durability. When aluminum PCB and aluminum sandwiches boards were heated from 30 degrees Celsius to 140 degrees Celsius, the size changed by 2.5 to 3%. Thermal transmission is 10 times faster than with a traditional stiff FR4 PCB. Heat dispersion is far preferable to that of ordinary FR4 structures. Increased power density could be achieved whereas equipment remains cool, extending element life and resilience. Dielectrics can be customized to meet your thermally and insulating needs. Systems with efficient cooling qualities can be driven harsher or derated for lower cost materials. It is possible to obtain the simplicity of both a heating sink and a PCB. That ensures you have not only the thermal properties of a heating element but also a PCB layout that is both cost-effective and small. This always allows for quick heat clearance from lead technology to avoid burns. By combining a dielectric polymeric covering with high thermal conductance levels, a decreased thermally resistivity could be achieved. The heat is dissipated by the laminates in the MCPCB, providing optimal heat managing and, as a result, longer operational life and improved productivity. Metals PCB layout and variations: aluminum cores PCBs, copper cores PCBs, and iron cores PCBs were the three types of metals PCBs now available on the marketplace, with aluminium core PCBs being the most useful. The following is a common metal PCB fabrication. Metallic base: a metal-based PCB, MPCB, is made up of metallic substrates, such as aluminum, copper, or stainless, thermally conductive insulating, and copper circuits. MPCBs were employed in a wide range of industries because of their exceptional heat dispersion. They're commonly found in power supplies, LED lights, and other places where heat is a significant problem. Dielectric: the dielectric overlay is laminated along with a copper layer on the surfaces on an anodized, protected metals foundation. It is normally 50-200 thick and serves as an insulated covering. This could work as an insulating to avoid short-circuiting with the basis of the metal if it is too thick, and that will reduce heat dispersion. This could disperse heat efficiently if it is too thin, but it is simple to short-circuit. Copper: to boost peeling resistance, the backside of the copper foil is chemically oxidized, and the surfaces were galvanized and brass plating. Copper was generally 0.5/1.0 Oz in mass. Why is it necessary to utilize a metals PCB? Dissipation of energy: most double-sided and multi-layer PCBs were currently high-density, high-power boards with poor heat dissipation. Conventional platforms, including FR4 and SEM3, have poor heating conductivity because they are enclosed among levels, and heat could not be dispersed, resulting in a high-temperature breakdown of the components. Protected metal substances, which have a heat dispersion capability 5 to 10 times that of FR4, could address this issue. Expansion: due to heat resin, reinforcement materials, such as glass fiber, and copper foil make up traditional printable circuits boards. In the z-axis dimension, the thermal expansion coefficient, CTE, of the substrates, whereas the CTE of copper, implying that the CTE of the metallized hole walls and the insulation sealing of a typical printed circuit board are vastly different. If the produced energy is not removed promptly, thermally expansions and contractions would shatter the metallized holes, resulting in faulty electronic devices. That issue is exacerbated by SMT, interface mounting technologies. Because the contact is made by solder directly across the metallic pads and the SMD, the CTE differential among the ceramics chips and the FR4 substrates was likely to induce connections fracturing over time. The metals PCB could efficiently control the thermal transfer issue, reducing thermal expansions and contracting and enhancing the electronics equipment's lifetime and dependability. Stabilization in dimensions. In terms of dimensions, a metal PCB is far more dependable than a regular PCB. For instance, the dimension variation of an aluminum core metals PCB heated from 30 degrees Celsius to 140 degrees Celsius is 2.53%. High heat dissipating substances protect parts from overheating and damages, and a metals cores PCB or an aluminum cores PCB may be the best option because it effectively works as one giant heatsink. Interested to know more about metal core PCB boards, or PC board assembly? Contact us at sales@pnconline.com.